Hey guys, so in this video I'll be solving question 5 from the tutorial sheet 8, and it reads: show that the static friction force between the block A and the surface can hold the system in equilibrium for the weight of block A given. So it says given that d nu is equals to 0.3. Okay, so what other data have we been given? Okay, so we can just say weight A is equals to 90 newtons, then the weight is equals to 15 newtons, then we have T1 which is unknown, T2 and T3. All these can be solved, right? T3 can easily be solved to be 15 from the figure, 15 newtons. Okay, so what we are going to start with is first look at the question. It says we need to show that this can hold the system, right? So the condition for this to happen, it means the force of friction, which is force of friction, should be greater than or equal to T1. So you just have to prove this. You just have to find the values of the force of friction and also the value for T1. If the force of friction is equal to T1 or greater, then it shows that the weight of A can is able to hold the system. Okay, so let's just say solutions. Okay, so what we'll start with is the calculation for force of friction. Okay, so if we look at the force of friction, we'll draw the system. We have the force of friction in this direction in the table. Then we have T, and then we have 90, and we also have the normal. So we get that force of friction is equals to mu n, right? Where n is equals to the weight of the block A, which is 90 newtons, right? I'm sure we understand the basic concepts that are found there using summation of forces in the Y. Then from here, we'll say F, which is the force of friction, 0.3 by 90, which is equals to 2.7 newtons. Which is equals to 27 newtons. Okay. Then we now do calculations for T1. So for T1, we have our figure like that. This is T3, this is T2, this is T1, and we're given the angle there as 45. So first we need the components. So we'll look at the components. Okay, so we have the vectors, we have the x component, and we also have the y component. So the first one is T1, then this in the x, so it's going in that direction, this is in that direction, and this in that direction. So we have T1, so we say positive or negative, positive or negative. So this is negative, this is negative, not positive. Then here it's 0. Then for T2, T2, we have T2, which is positive, cos 45, and again positive T2 sine 45. Then okay, so from here, let me write T3 on another page. So we have vectors, meaning T3 will be equal to the x component of T3 will be 0. The y component will be 15. Then positive or negative, this is in a negative direction. Okay, so after we find the components, we need to calculate for, or we need to solve for T1. So I'm going to say, I've already written solutions. We say solve for T1. Okay, so to solve for T1, we say that it's in the x component where we have T1. So we'll come back to our equilibrium conditions, and summation of forces in the x should be equal to 0, which implies that minus T1 plus T2 cos 45 should be equal to 0. This simply means T1 is equals to T2 cos 45. So at this point, we notice that we don't know T1, we also don't know T2. Therefore, we can now go back to our equation and look at summation of forces in the y. We see that we have T2 as the only unknown in this equation. So therefore, we'll say summation of forces in the y is equals to 0, which implies that T2 sine 45 minus 15 is equals to 0. This simply means T2 is equals to 15 over sine 45. Okay, so we'll substitute for T2 here so that we get T1. So T1 is equals to, where there is T2, I'll put 15 sine 45 cos 45. So you can either do this on a calculator, or just, we know cos 45 and sin 45 are equal, therefore this will be equal to 1. So T1 is equals to 15 newtons. Otherwise, if you have to punch in on your calculator, you say cos 45 divided by sin 45 and you get 1. So that's how you get your 15 newtons. Now, we notice that we found that F of friction is equals to 27. Then, and T1 is equals to 15 newtons. So the condition was F of friction should be equal to or greater than T1. And we notice that 27 is greater than 15 newtons. Therefore, the weight can hold.